Hello everyone, this is a video going over the solutions for homework 2, and let's start out by calling the import statement here, and then go to the first problem that asks us whether if we have a dictionary to actually get the maximum or minimum of the value or the keys. So the way to do this, and there's a number of ways you can do this, but if we write a function, first of all, let's give it a meaningful name. So we have find min or max of dictionary, then we provide the dictionary. Then in order to increase flexibility, we have the comparison function being passed as an argument. We could also have had a string that says min or max, and then we have the var variable that tells us whether we need a value, which is the default, or we can also pass the key. So what it does is, first of all, it checks whether the comparison function is min or max, because those are the only ones we want to use. And then if the var variable is equal to key, then it runs the comparison function that we gave it to on the keys. Otherwise, it runs on the values. So let's execute that, and then let's go here. Now, the first thing I wanted to do to show is by having this if statement here, if we pass a function that we don't want to actually have a solution, an answer for, it will give us nothing because it didn't have anywhere to go after this because this evaluates to false. So now let's go to maximum for the keys. That's 10. You see here. If we don't pass anything, that's the values, and we have the maximum here, which is 100. Now, if we pass something that's garbage, it will still give us 100 because again we have the default being using the values. Now we have the else statement here. Now, the second part of this was to exit gracefully if the input dictionary contains strings. And the way we do this, again, there's multiple ways to do this, but we have the same function signature, and then we have a variable that describes the state of whether we found a string. We initialize it with false, and then depending on whether we have value or key in this variable var here, we create this list, and it's the sequence of values that we want to check for. So again, we have check vals, and this is, I wanted to show this is a one-liner that is replacing an if-else block. And sometimes if you have something this simple, it makes sense to just have a one-liner, improves readability. But essentially what it does is it says check vals, put values if the var variable is value, or put the keys. Now the check comes here, so if we find, depending on what we ask for, if we find a string or in the values or keys, we check whether it's the v value that iterates over check vals. If it's an instance of a string, then we set the state variable as true. So after we finish the iteration, this will be either true or false. And then we check with not found string. So if it's true, not true means false, so this doesn't get evaluated. So we go here to that branch. However, if it's still false, then not false will be true. And then we also have this check of the comparison functions. And then the same thing as before. So, and here you see how I've omitted the keys attribute because by default the D will give us, well, the dictionary itself will give us the keys if we don't have any attributes there. And then if any of these conditions is false, or both of these conditions are false, then we will pass. So we will not do anything. So let's try this. And now let's do find min, and then let's provide a dictionary. So just these two, and then we'll pass the minimum. Okay, so see, it's working because again, by default, it has the values. So let's see if it's working with the key, and it doesn't return anything the way we expect it to. before, because again we're looking at the values, we didn't find a string, so it worked. So again, there's a number of ways to do it, but this would be one of them of how we can extend the function from above. Now for the second problem, we had a list of tuples with latitude and longitude pairs, and then we needed to write a function that creates a list of only the latitudes or longitudes. And one thing we're doing here is that, again, we give a meaningful name to our function. We have the list, and then we have a variable that tells us whether we want the lat or long. So in order to increase flexibility, if the user provides, let's say, latitude or longitude, whole words, or has some capitalizes any parts of the word, what we do is we can use something that's called, well, first of all, we can just check whether the lat or long variable starts with lat. But again, as I said, that might be capitalized, so we need to do something that's called function chaining. So we chain two operations to this variable. The first one is dot lower, and again, lower is a function that's contained within the string object. So we have dot lower. So this will return a string, the lowercase version of the string, and then we chain another function, dot starts with, which again is part of a string, and if it starts with lat, it will return true. In that case, we set the position of the value we want to extract from the tuple in the list to 0, the first element. Otherwise, we grab the 1 if it starts with longitude, and if none of these match, then we say that the position is none. So if the position is a null variable, then we just say invalid option provided. And then if that's not the case, so we have a 0 or 1, we use something that we talked about on Thursday, which is a list comprehension, and we have the, again, it's like a for loop, but it automatically creates a list without the append and empty, starting with an empty list. So we have for L in lat long, so for every tuple in the list, we grab the first or second element depending on what that position variable was set as, and then we return the output list. So let's run this, and now let's try to run here with extract lat or long of the geo list. There we go, we grab the latitude. So what if we provide this? Again, we get the same thing. What if we have this? Same thing. And now we get the longitudes, and again, you see how we've increased flexibility, but also what I wanted to show is the chaining of the functions. All right, and the last part is writing a function that finds the closest location, just using the minimum Euclidean distance. So simple. So we have, if we set, let's say, the point 2, so we got the latitude longitude here, setting to 26.3 minus 110.4. And with that, what we do is, first of all, we import the square root. And one way, again, to find it, as I said, there's a few ways to do this, but for example, you could create a list with all the distances and then find the minimum of those. Or you can just have, you can do it the more traditional way where you set an initial value of the distance to a very high number, highest that you would expect. So here we just use 9999. And then we have the closest point as 0, 0. So that gives us the latitude and longitude as a tuple. So as we are going through, iterating through the geo list, we calculate the distance. And that would be as the latitude minus the latitude of the location that we passed, squared, and then the difference here, squared, take the square root. Now, if the current distance, c dist, is less than the d distance that we set up here, which in the first iteration it should be because this would be a very large value, then we set the d variable as the current distance. We set the closest point as the point we are using currently, and then we go through the iteration again. So if this again is true, then we replace the values. By the end of the iteration, we should have the closest point. All right, so let's test it out. So find closest geo, and then we pass the 26.3 And there we go. So this finds the closest point from the latitude longitude list.